So that's our tutorial. We ended on number 3, isn't it? A brick is dropped is 0 initial speed. When something is dropped, then it has 0 initial speed from the roof of a building. The brick strikes the ground in 2.5 seconds. You may ignore air resistance, which you always be doing. So the brick is in free fall. A, how tall in meters is the building? So I'll give you this thing on your study master when you are done with this class. Then B, what is the magnitude of the brick's velocity just before it reaches the ground? C, sketch acceleration time graph, velocity time graph, and the position time graphs for the motion of the brick. So you did block on Adipona, then to the Sangama values. So these things are very simple. For how tall is the building, you just say H equals V naught T minus 4.9 T squared. H equals V naught T minus 4.9 T squared. As you've seen, there's no why not what, because the top of the building is a reference. So this equation, we've already been taught that the brick falls with 0 initial velocity. So apapati V naught, you put 0. Then the time is 2.5. Except when you multiply anything with 0, the answer is 0. So minus 4.9. Then where there's time there, you substitute the 2.5 seconds. So H equals 0 minus 30.652. So the height is minus 30.652 from where you're dropping, because you are on top of the building, then you drop the brick. So meaning the building itself is 30.625 meters tall. So you will go and finish it up like that. So you say H equals 30.625 meters tall. With the velocity, you go with the 3. You go with the 3, you say V equals V naught minus 9.8 T. Remember that 9.8 T, 9.8 is the G. So that's how it is. So V naught, the initial velocity is still 0. So 0 minus 9.8 times 2.5. So the velocity is negative 24.5 meters per second. It makes sense because for something to be dropped, then it's falling down. The velocity for something that is going down is always negative. The velocity is only positive if something is going up. So that is the reason in there. So to plot the graphs are almost standard for this kind of motion. So acceleration time graph, we said the acceleration is constant. So acceleration is your y-axis. Just like this is ugly when I drew it. So you just sketch. So you just draw a straight line here, a vertical line. Then somewhere below 0, you put negative 9.8. Then you draw a straight line, which is parallel to the x-axis. Then that's all for the acceleration time graph. It shows that the acceleration is constant throughout. So since you're plotting acceleration, that's how you plot acceleration time graph. For any type of motion that will be plotting, acceleration time graph is what if to draw a fin. You just put the times in the question and then you plot like that. For velocity time graph, velocity is coming from 0 and it's a straight line. So velocity time graph, you draw a line like that. Because this is free fall. For all free fall, as you remember, for free fall, we said that the velocity is always decreasing. When you throw, even if you've thrown up, the velocity is always decreasing. So now, since you're coming from 0, so the decrease is like that. So that's how you draw the velocity time graph. You master. This is for when you drop. We'll do another question for when you throw up. Yeah. Then acceleration time graph is almost always a what? A quadratic. Acceleration time graph is almost always a quadratic. So since you are dropping from the 0 initial point, that's your 0 displacement point. it should always be a graph going down like that. The quadratic half of a quadratic parabola nishichapwa. Half of a quadratic parabola nishichapwa. As we've seen, nimbikako maximum a panshi after 2.5 seconds. It was 30.6 shanshanuko a. Then this is the before it strikes the ground. Then you plot like that. So these are the plots. Just go and go through them. Sometimes the but the good thing is that they are monotonous. You just do the same things throughout. So we got to this other nice question. Veronica angrily throws her engagement ring straight up the roof of a building. Straight up the roof of a building, 12 meters above the ground, with an initial speed of 6 meters per second. A, how long is the ring in the air before it strikes the ground below? B, with what velocity does the ring strike the ground below? C, calculate the average velocity of the ring. D, calculate the height from the ground to the maximum height attained. So that's the reason in there. So the velocity of it being given as 6. So we come to number 4. So this is the equation that we use to find the time. This question is not very popular because it makes you do quadratic, and as we all know, quadratic formula is not something very familiar to a lot of people. So this is what you write for height. So you say h equals v naught t minus 4.9 t squared. Then where there is h, you put negative 12. You put negative what in? 12. So you say negative 12 equals 6t minus 4.9 t squared. Then you make the quadratic equation. The quadratic equation is made when you equate everything to 0. So you push these two, 4.9 and 60, you push them this side. 4.9 is negative, so it becomes positive. 60 is positive, so it becomes negative. Minus 12 is equal to 0. Then you do the quadratic formula. A is 4.9, B is minus 6, C is negative 12. Then you remember that T equals minus B plus minus the root of B squared minus 4AC over 2A. Substitutions there, that's your job. Except, I just want to emphasize upper, when you're doing minus, this one is minus 6 squared, you can even just say 6 squared. Because whether a number is negative or positive, when you square it, the answer is always positive. So it's acceptable that you drop this negative if you want. Because sometimes when you're substituting negatives and you're inputting them, they confuse you. You may find now start square is negative. When you square here, the answer must outrightly be positive. When you square a negative or a positive, the answer is always a positive one. So that's why sometimes we put just 6 squared. Then some of you may ask, why have you taken the negative? It's because I know that whether it's positive 6 or negative 6, when I square it, the answer will be 36. So that's the reasoning. Then you solve. Uksolve quadratic tends to end here, this is mathematics. But when you work it out, the only thing is that it's time we're looking for. So the only root which we'll get is the one that gives us positive time. Because there's no way now uposa ring, now uposa imbalamino. Then yasa pona waposa lelo yapona mailo. Yapona yesterday. It's not possible. So the only time that you get is the future time. Because negative time means it's a time in the past. And these are futuristic events. So the only answer, quadratic equation answer yabidi, where you are subtracting and where you are adding. So when the only answer you pick is the one that gives you a positive answer. Time is a scalar quantity, so only positive answers are allowed. If it was velocity, you find both the positive and the negative, because velocity is a vector. Vectors are either negative, they follow that number line, whether negative or positive. But for time, the only answer you must pick must be positive. So that's why you get t equals 2.29 seconds. More years at them. Yep. So apa what's negative b. So it was minus 6. 6 up. You must remember that your algebra, when you multiply two negatives, they give you a positive. Then you are found. Then b is with what velocity does it strike the ground? You use this formula. If you want, you can even start with this one, b, because it's very straightforward. You say v squared equals v naught squared minus 19.6 h. Remember, 19.6 is 2 times g. So it will be v squared equals 6 squared minus 19.6 times minus 12. So when you multiply there, you will find yourself adding. Apa pa fide plus up plus up. So mubike po plus up. But now I'm fin pa the plus up. So you find yourself adding because this is negative and this is also negative. So when you add them, they'll give you 71. Then when you find the square root, the only root you will pick is the negative one because they're asking you with what velocity does it strike the ground. For something to strike the ground, then it's falling down. Are we together, guys? So that's what you get there. I'll put the answer, I'll make this correction, I'll put a plus there. Plus, then I'll get a picture, then I'll make the PDF again, then I'll send to you. So that's all you're supposed to do. So this is it going downwards. Ngode fire, in a time, you can say V equals V naught minus 9.8 T. The reason why I picked this formula is because it doesn't use this T. Na quadratic, so it means B. So I preferred that you use a different formula that does not involve using a value or you calculated yourself and that has to be marked. If there's that option of using a value that you have calculated, then option you can either use or not. It's better you don't use because it's possible meaning na A nga wafa nishina B na yo wafa. So that's the reasoning. So you must make sure you understand these concepts very well. So that's why I picked this one. But those of you who are trying V equals V naught minus 9.8 T, your answer you find V naught is 6. So it will be 6 minus 9.8 times 2.29. The answer will almost always be approximately that. So that's all. Then for C, they're asking us for the average velocity. Average velocity, there are two ways of finding it. You can either say h over t, which is displacement over time. The displacement in vertical is the height. So h over t, which is negative 12 over 2.29, wasanga negative 5.24 meters per second. Or if you want, you can say v naught plus v over 2. Okay, you just have initial velocity and final velocity. So it will be 6 plus negative 16.468 over 2. All of that over 2. So the answers are almost similar, except probably negative 5.24 are power negative 5.23. It's very much allowed because as we are working, especially with the quadratic, you saw that these are around the off values. So it's very allowed that you can miss by a single decimal in the hundredth. In the hundredth, you can miss a decimal. Then the next one is what is the maximum height from the ground? So now from the ground, you use the height of the building where she's throwing from as the initial height, as why not? Because now you're not doing your calculations based on the top of the building, but you're doing them based on the ground. So the height of the building becomes some addition of sorts. So a formula nachibika number v squared equals v naught squared minus 19.6 open brackets y minus y naught close brackets. So where there is that at the maximum height, always the velocity is what is 0. So if someone asks you what is the velocity at the maximum height, your answer must always be 0. Answer is always what is 0. So 0 squared, for navigator 0, when you square 0, the answer is 0. So you say 0 is equal to 6 squared minus 19.6 open brackets, the maximum height which we are looking for, minus the height of the building, which is something we'll end up adding in the end. So when you work this thing out and change the subject to a formula to y max. First of all, you open the brackets. When you open the brackets, you discover that apa wala bikapo plus. So you should remember that. Then when you work this thing out, then wala so sangati, the maximum height is 13.84 meters. So nishi ata question. Are there any questions? Are there any questions? Okay, you are mute.
Yes,
Number 5.
Sir, I have a question.
Yes, Stephen.
Sir, I had time understanding the question. It says the ring was thrown up, like vertically
Yes.
up. So meaning, doesn't that mean at some point, say, the initial velocity was 6, and then after it reached the maximum height, the maximum height before it started dropping down again, or did it drop down, or what happened? Because okay, I had it.
It falls down back to the ground.
Yes, it falls back to the ground. So
Yes.
there is so after it's thrown up,
Yes.
At some point there, it stops. The velocity becomes 0.
Yes, then
And
becomes negative. Nice accent. We watch the news. Yes.
Yes, and then starts. Yes, and then it starts dropping down again. So
Yes.
I thought maybe for calculating the one that it was going up, you use maybe a different equation. You use some equation, and then you add it to when it was like dropping down again. You add those times to get the total time that it was in the air.
Oh, nice accent, so, Mr. Stephen.
Thank you.
What I want to say is, well, Stephen, this is the second time you're asking about equations. They have confused you. But what I've said is for free fall, the equations must always be uniform. The equations are just the same. My equations. So what I wanted to emphasize, Mr. Tembo, is that you still use these equations always, except the only thing that varies is velocity. When it's going up, this 6, if we threw up, this 6 should be plus, positive, because going up for velocity is positive. Then if we threw down with 6, instead of putting positive 6 here, we could have put negative 6. That's all. But the equations are always the same. They're always the same, but you only be changing them regarding the velocity, the way you've been given. The velocity can either be 0, that's if you're dropping, 0. If you are throwing down, a negative velocity. If you are throwing up, this will be positive velocity. It does not, the motion is on its own. It's a same motion, except when you are finding your answers, you discover that at some point you find the negative answer, at some point you find the positive answer for height. It means when you find the negative answer, it means the ball has already passed the maximum height and is falling down. If you find the negative displacement, then it means it's even below where this Veronica threw the ring from. So that's all. The equations, Sir Mr. Tembo, do not change. The only thing that will change is the substitution. When you're substituting, say, the initial velocity, the velocity when you are throwing up will be positive. When you are throwing down, the velocity will be negative. When you are dropping, the velocity will be 0. That's all. Don't you make sure my equations? That's what I'm whatever case is happening, the equations are the same. The only thing that will differ is the substitution. How would you substitute the values? Because this one is falling below you, 12 meters below. It's falling. That's why it's negative what? 12. Mr. Innocent, sir.
Oh yeah, I've understood, sir. I wanted to ask as you're on the negative 12.
Okay.
Now you've cleared me.
Okay, sir. Achala wa mumulesa mu school tukesa pita mu lubiro tonse fyo marathon two lessons so ati muke katika ikabe cast mumitu. So that's how it is. So the next question. An egg is thrown nearly vertically upward from a point. Give mommy. An egg is thrown nearly vertically upwards from a point near the cornice of a tall building. The egg just misses the cornice on its way down and passes a point 30 meters below its starting point 5 seconds after it leaves the thrower's hand. Ignore air resistance. So the only thing that you've noted is that velocity acceleration tabatipera acceleration. But per earth it's 9.8. Almost always 9.8. Nasaleta proportion ya kumuni nadeka nokuleka. Abantu yali ni example yali per earth. It was over per earth example. Then the only thing I changed from that very example was I said now it was on the moon where the gravity is 1.6. So now the coffee akola ku moon. Ili apa earth to adiumfira nomba ya afya vitu amboga na afya ku moon. That's how it was. So A, what's the initial speed of the egg? B, how high does it rise above the starting point? C, what's the magnitude of its velocity at the highest point? And how long does it take before reaching the highest point? D, what are the magnitude and direction of the acceleration at the highest point? Then E, you sketch acceleration time, velocity time, and position time. So apart from it to change question, I'll go and change this should be YT, not AY. It should be YT. I'll change something. I've promised if I change so when I put, so I won't close the start master, then you'll get your PDF from there. I won't close it soon. So that's how it is. So now guys, when you're going now, the acceleration time. This one, D, acceleration is always 9.8, regardless whether it's at the highest point, whether it's just before you throw, just after you throw, just before it hits the ground, the acceleration is always constant. So D na kusangira fedimo 9.8. Now max mukalamu Africa 1 mark, 2 marks, because all they want you to know is that acceleration is constant. Are we together? So now let's go to the answers. D na sangira dimo name about acceleration. So let's go to number 5. So it reaches a point 5 meters below. So kubomfia equation H equals 30 meters below after 5 seconds. H equals V naught T minus 4.9 T squared. Equal term of V naught here, then if you say not quad. So by the H you put negative 30. Why? Because they said 30 meters below. So 30 minus 30 equals V naught times 5 minus 4.9 times 5 squared. When you work this in out, 5 squared is 25 times 4.9 to give you minus 122.5. So minus 30 equals 5 V naught minus 122.5. Then the 122.5 can go this side. Put 5 V naught you remain with, when you subtract this positive minus 30, it will give us 92.5, which is equal to 5 V naught. Then we divide over 5, we get 18.5 meters per second. That's how it is. Then B, B is how high above the starting point does it go to? Let's go to B. It equals a B. How high does it rise above the starting point? So how high does it rise above the starting point? Remember, at the highest point, velocity is 0. So you do use this equation. Always V squared equals V naught squared minus 19.6 H. We're looking for the H. So 0 equals 18.5 squared minus 19.6 H. Then you solve for H. You find it 17.46. Then the other one is time at it reaches the highest point and also the velocity at the highest point. The velocity at the highest point is 0. Always 0. Velocity at the highest point. Max 2 max. 0. Then time, you use the first equation of motion. 0 equals V naught minus 9.8 T. So 0 equals 18.5 minus 9.8t. This one crosses there, then you find 1.89. Let's see. Niche chapter. Then for the graphs, they are the same graphs. Acceleration time na nime watini moine kubika mfya ishtashide muli question or draw a normal line was straight niche chapter. Then for velocity time graph, taidiambila pa 0 because it's not dropped. It's starting with the initial of 18.5, but then you remember at 18.5 is always reducing until it becomes 0, then it becomes negative. So graph imoneka so. This is the most asked about graph. Now, when you picture the graph, you will discover that most always is always the velocity time graph, and it takes this shape. Time to reach the mass amount is not as 1.89. Washida papa pen up. Then naka 5 to kabika faka belera, but ngawika 1.89 hapa, wabika neine. These are the 2 points. If it's on a graph, could draw. So you just connect these ones and draw a straight line. You're done. That's all. So if the figure goes on for the question, if it's negative 30.5, I solved after 5 seconds. What's the velocity? I used v equals v naught minus c 9.8t. I got negative 30.5 so nishwa draw. This shape of graph, stick it to your memories because ilesa sana. Then position time graph, as you remember guys, I said it's quadratic. Kind of beautiful, but I know you can draw something more beautiful. So you draw upper 1.89, 2 times 1.89, 3.78 a. So then you draw a quadratic graph. Yafika hapa. Since dile ponona munshiri we, yapo na quadratic yasa na kunshi. Hapa nimekapo negative 30, hapa 5 inch hapo. So that's how you go about that question. So the graphs, it's just a concept of just understanding them. That's how it is. Number 7 and 8 are just simple quiz questions. Tuyabika mufipakti yesu sheku fekanda kawami mukala apita mumwebeni. Nukwisa is rare that kutia isa. Especially that ne examiner nene. Taking the question here, so tabadi abantu yo. But kukabika feso atiti sharpens your mind. That's how it is. A large boulder is ejected vertically upward from the volcano with a speed of 98 meters per second. Air resistance may be ignored. At what times after being ejected is the boulder having the speed of 30 meters per second? When is the displacement 0 from its initial position? When is the velocity 0? Velocity 0 at the maximum height, I know you know. Then D, what are the magnitude and the acceleration and direction of the acceleration while the Buddha is moving upward, downward, and at the highest point? Then next is sketching. So D, I've already told you for acceleration. I'm going to push a question. Acceleration is constant for free fall. It's 9.8. For all 1, 2, 3. So I'm going to pick 3 marks and 6 marks in Shuaka Pokafe. Why? Because the acceleration is constant. So that's how it is. So we will go. So I'm going to for a number. The question says, at what times? At what times? Meaning there are 2 times when the speed will be 30. The first one is when it's going up. The second one when it's coming down. The speed will be 30 twice. Except for velocity, it means when it's going up, it's positive. When it's coming down, it's negative. So that's what you go to. So you say number 6. Whatever velocity. So you say V equals V naught minus 9.8t. So for going up, your V will be plus 30. For coming down, V will be negative 30. That's all. Then you substitute. This is your initial velocity, which is 98 minus 9.8t. Then you solve. So you say 98, 9.8t equals 98. Iya crossoku, iya 98 minus 30. So it's 6.94. Then foot again, you do the same. A power backup number negative 30 when it's coming down. Okay, speed is the same. Speed is scalar. You just report speed as speed. But for velocity, you specify that you see positive going up and negative coming down. So minus 30 equals 98.9 minus 9.8t. Then you solve also, change the subject to 9.8. You discover that 30 when it goes here, it becomes positive. The 9.8 becomes positive, also going the other side. So you get 13.06. So that's the reason in there. Then when is the displacement 0? Displacement in h. So you make the equation here h. H equals v naught t minus 4.9 t squared. Kuli h lubali uku wabika ko 0. So you say 0 equals 98 t minus 4.9 t. You don't just cross this and cancel out t. No, you factorize. Because for these values, 0 is very important to physics. 0 is also a very valid answer. So you factorize, you say t, open brackets 98 minus 4.9 t. So t is 0. Also, when you solve, t is 20 seconds. So that's the way it is. Then the next is, when is the velocity 0? The velocity 0 is maximum at maximum. So you could be 0 could be velocity 0 equals v naught minus 9.8 t. Why? Because we look for time. When they ask you when, it means they're looking for time. Then when you solve for time, you get 10 seconds. Here acceleration and then the velocity time graphs. Here line to draw, here acceleration just a straight line. Here velocity you push 98 yoku na negative 98. Upper 10, upper 20. So this 20, if you've noted guys, the displacement is 0 parallel posa. So ngayabwera back is after 20 seconds. So meaning to take the same time 10 seconds going to reach the maximum height, another 10 seconds coming back down. So a reason ibererati, apart B answer ni 20, C ni 10. So if you can reason like that, wasaramfati, half of that wasanga ni shife wun. Then the last one ni shini quadratic. Kusanga fe what the maximum height is. Gawasanga wabi kaka position wabika na 10 na 20. What draw na quadratic graph. Nishi